Okay, confession. At the end of the last video, I said that topic 3 was topic 2, but it's okay because we are done with topic 3, and now we're on to topic 4. Topic 4 is talking about the arc lengths. If the circle below has a radius of 15 centimeters, find each arc length. Okay, I'm up for the challenge. The radius is 15 centimeters. I'm going to label that so I don't forget. My arc VW is, I have to figure out what portion of the circle is the arc from V to W. So I know that around the outside, halfway around, so if I start with Y and I go around the outside of the circle to V, Y to V is a diameter. So that total arc is 180 degrees. I want to know just that leftover part though. The first section is 26 degrees. Since there's a right angle labeled, this is 90 degrees. And then V to W would be the rest of the length there. I get it. We're trying to find the length, but I need to know how many degrees we are accounting for of the entire 360 before I can use that to find the actual length rather than just the measure, which tells me how many degrees there are. 180, subtract 90, that's easy, that's 90. Take away the 26, that's going to get me 64. That means this part of the circle here accounts for 64 degrees of all of the 360 degrees around the outside of the circle. I need to know, well, what distance would I travel if I went around the outside of the circle? The distance I would travel is the circumference. If I need a circumference, I just use pi d. So my circumference around the outside of this entire circle is pi times, my radius is 15, so that means my diameter is 30. So my circumference is pi times 30. My circumference is 30 pi. What does knowing the length around the entire circle have to do with anything we're talking about? Well, 64 degrees is only a portion of all the way around the circle. I'm wondering, what portion of the circle is that? Well, it's going to be the length from V to W is going to be only 64 of the entire 360 degrees. That's the fraction of it, of the entire length, which is your circumference. If I want to reduce 64 over 360, I can just divide it. 0.177777, I can't remember what that is as a fraction. So what if I just reduce this in my head? 32 over 180. I could reduce that to 32 over 180. Let's reduce that again. That's going to be 16 over 90. Can I divide those by, this is only divisible by 2's. That's 45. Okay, 845 over 45. Okay, so that's what I'm left with there. So I have, it's the same thing as 8 over 45 of 30 pi. And 8 times 30 is going to be on top. And that's going to get me 5 1/3 pi. So I could say 5.33333 pi. I do not like to live my life like that. 5 1/3, that's 15/16 thirds pi if you reduce it. So that is the length of the arc as long as I put centimeters on there because we label our answers. Arc UXV. UXV. Ooh, that's around this entire part except for, it's around the outside of the entire circle except for that little section that's 26 degrees. Because these are vertical to each other. So that means this is 26 degrees. So if I'm wondering about the length that goes all the way around, the portion of my circle that I'm dealing with, rather than it being 64 of the 360 degrees, I'm going to say that it's, well, what's left over if I take away 26 degrees? 360 without 26 of the degrees. I'm feeling a 334 degrees. So 334 of 360, that's the portion of the circle. And we're saying the entire circle is 30 pi. Oh, this is better because now I know how to reduce 30 over, my zeros cancel. And then I can divide 36 by 3. That's 12. So 334 divided by 12. As a fraction is 27 and 5/6. So UXV is 20. 167/6 pi centimeters. Good.